This episode of Mathematics with Mr. Richardson has been brought to you by Hilton Hotels and Resorts, downtown Anchorage, Alaska. Reminding you, at Hilton, if you're not satisfied with your stay, let us know and we'll make it right. So we know how to FOIL when multiplying a binomial times a binomial. We know how to distribute when multiplying a binomial times a trinomial or a larger polynomial. But what about the inverse of those operations? The inverse of multiplying binomials or trinomials and simplifying to find a polynomial. Well, that's called factoring. It is undoing that multiplication. And we're going to learn a lot more about that in section 8.5. The objective of section 8.5 is to factor trinomials of the form x squared plus bx plus c. An essential understanding for this section: you can write some trinomials of the form x squared plus bx plus c as the product of two binomials. We'll be exploring this a lot more in section 8.5. Here's a good real-life problem to get us started thinking in this way. It says the area of a rectangular solar panel is given by the trinomial x squared plus 7x plus 12. The height of the solar panel is x plus 3. What is an expression for the length of the solar panel? And explain your reasoning. So first we should recall the area of a rectangle. In this case, since the rectangle is standing upright, we can think of those as being height times width. Now we're given an expression to represent the height of this rectangle, and our job is to find an expression to represent the width. So considering what we know the area of this rectangle is written as the trinomial x squared plus 7x plus 12, and our job is to determine how that can be written as our height, x plus 3, times some other expression. So perhaps we could try this: x plus 3 times some monomial constant like 5. In this case, we would distribute the 5 to both terms in the binomial. And find 5x plus 15. That really didn't suit our purpose. We need to get an x squared. So perhaps if we multiply by a monomial variable like x. So here we go. Pardon the multiplication sign x and the larger variable x. But again, in this case, we would distribute the x to both terms in the binomial to find x squared plus 3x. Well, that's getting us closer. Perhaps we need more than one term. Perhaps some binomial, when multiplied, will get us back to the area we're looking for. And so I'll begin this way: x plus 3 times, and I kind of have a placeholder here for a binomial, but I haven't finished it. I know that when we FOIL our two binomials, we'd like to multiply first, outer, inner, and last in order to get back to the polynomial x squared plus 7x plus 12. And I recognize that x times x, when we multiply our first terms, will yield x squared. But now I'm going to consider our last terms. Remember, at the end of FOIL, we'll multiply our last terms. In this case, one of our last terms is 3, and the question is, what must the other be so that when we multiply our last terms, we get the constant in our polynomial area, which equals 12? Well, I believe we can all agree that 3 times 4 is 12. So let's check this out. Here we have two binomials, and when we FOIL those, we multiply first, outer, inner, and last terms to arrive at x squared plus 4x plus 3x plus 12. Combining like terms, we find exactly the solution we were looking for. Therefore, the binomial x plus 3 times the binomial x plus 4 gives us the area we wanted, and that tells us that the width of this solar panel must be x plus 4 units. So as mentioned earlier in the section, you can write some trinomials of the form x squared plus bx plus c as the product of two binomials. To understand how, consider the product of binomials. Note the color coding in this problem so we can track the places where the 3 and the 7, our two constants in our binomials, end up in the polynomial at the right. As we multiply our first, outer, inner, and last terms, and arrive at the final polynomial x squared plus 10x plus 21, note that 10 is the sum of our constants, 3 and 7. And 21 is the product of our constants, 3 and 7. Realizing this will save you a lot of time as we move forward in the section where you will be asked to factor on your own. Here's an example. Factoring x squared plus bx plus c, where b is greater than 0. Note that means b is positive, and c is also greater than 0. The question is, what is the factored form of x squared plus 8x plus 15? You can list the pairs of factors of 15, identify the pair that has a sum of 8. And while I appreciate the way that the book has this lined out with a nice, attractive table, I'm going to show you the way that I do this problem. I begin with x squared plus 8x plus 15, and I recognize right away that is of the form that's discussed here, the standard form of x squared plus b times x, right, where in this case b equals 8, and plus c, and in this case c equals 15. Remember, b and c are just placeholders that could take on the values of any number. So in this case, 8 and 15. And then I begin by creating the framework. For the two binomials, I insert an x and an x for our first terms, because I recognize that x times x will yield x squared, and that's really what we're looking for. Then I begin to think about two constants. Constants that will go in this place and this place. But I know that those two constants must, when multiplied, equal 15. Right, at the end of FOIL is L, or multiply the last terms, and those last terms, product ends up being 15. So two values that when multiplied equal 15. And here we can list the factors of 15. Well, 1 and 15. 2 is not a factor, 3 and 5. And that's it. I mean, we could think about 4, no, 5. Well, by the time we get to 5, we've really just flip-flopped these factors. So 3 and 5, 1 and 15, and then I look back to our value for b, or in this case, which of the pairs of factors add up to 8? Well, that's pretty easy. It's 3 and 5. So plug in a 3 and a 5 and check by foiling. First, outer, inner, and last, which give us and combining like terms, so checking our answer, it works. And your first opportunity to show that you have got it. What is the factored form of r squared plus 11r plus 24? Work carefully and make your selection from the choices below. This brings us to the idea of a polynomial, in this case a trinomial with 3 terms, that has a b value less than 0, so a negative b value. Again, I appreciate the way that the book has laid this out so nicely, and I'd encourage you to pause it and check out that example. It may list some things that help you learn in a different way, possibly a better way, possibly not, than the way that I'll show you this problem, again on the right-hand side. So I begin by copying the problem, x squared minus 11x plus 24, and I set the framework again for two binomials. I know that our first terms need to have a product of x squared. I also know that our last terms need to have a product of 24. Considering the factors of 24, I'm now searching for two that when added equal negative 11. But we've got a problem. 24 plus 1 is 25, 2 plus 12, 14, 3 plus 8 is 11, 4 plus 6 is 10. None of those equal negative 11. We need to keep one more thing in mind. Not only does positive 1 times positive 24 equal 24, but negative 1 times negative 24 also equals 24. A negative times a negative is a positive. The same can be said for all of these pairs of factors, so perhaps it would better be written this way, with small plus or minus signs next to each of the factors, because, as we said before, not only does 1 times 24 equal 24, but negative 1 times negative 24 equals 24. So we need to consider not only the positive factors, but the negative factors as well. And that might help us in this problem. So again, we're looking for two factors that when multiplied equal 24, and when added together equal negative 11. That makes this problem a little bit easier for us. I'm looking at negative 3 and negative 8. I recognize that when I add those two, I get negative 11. So those will be the constants that we will write into our binomials. All right, and I'll do a little movie magic here and just blow the 24 and its factors away. Whoa, they're gone. I have no idea how that's going to work out after I finish editing this video, but it was fun to try. We'll see how it goes. So before all that silliness ensued, where were we? We'd found two binomials, and we think that when we multiply these using FOIL, we'll arrive back at the original trinomial. Let's find out. First, outer, inner, last. I see a match. I see a match. Therefore, we've checked our answer, and it works. Great. Another chance to show that you have got it. A. What is the factored form of y squared minus 6y plus 8? And B. Can you factor x squared minus x plus 2?